Welcome back to the second episode of electrolysis. Today I'm going to look at conductors, things which can conduct electricity, and insulators. For those who missed our first episode, I request you to go back and look at my channel. You will find a playlist known as electrolysis. Then you will watch the first episode, which talked about the introduction of electrolysis. Today we are looking at conductors and insulators, and a conductor is a substance that allows electric current to pass through it. So there are very many conductors. For example, we have things like graphite. Graphite is a conductor. We have metallic substances. These are also conductors. They allow electric current to pass through them. Metallic substances. We have things like platinum. And when you look at these two, we generally use them as electrodes. So you find out that electrodes can be in position to conduct electricity. At the other side, we have insulators. These are substances that don't allow passage of electric current. And among these ones, we have things like polyethylene. We have plastics generally. We have wood. We have rubber, among others. So there are very many substances which can act as insulators, and very many other substances which can act as conductors. In the previous episode, we talked about electrolytes. Electrolytes are going to be examples of conductors because they allow electric current to pass through them. And when you look at electrolytes, in our electrolysis, we shall have explanations trying to rotate around ability to conduct electricity in different compounds. So explanations involved in conductors and non-conductors. Which explanations can we come up with to explain why substances conduct electricity and why others do not conduct electricity? Number one, I'll look at electrodes. Stroke metals. Why is it that these ones can conduct electricity? What could be the reason that allows them to conduct electricity or electric current? These ones conduct current because or due to presence of free mobile electrons. So things like graphite will conduct electricity. Things like platinum, copper, aluminium, iron, among others, silver, zinc. As long as you are talking about a metal or a solid conductor, you will find out that those ones have ability to conduct electric current because of the presence of mobile electrons. The other substances are what we call ionic compounds. And these ionic compounds have ability to conduct electricity because of ions. So particles that conduct ions. In case the ions are free to move, then the ionic compounds will conduct. If the ions are fixed, then these ionic compounds will not be in position to conduct current. So under ionic compounds, part A, we are going to look at ionic compounds in solid state. If an ionic compound is in solid state, what happens? In this case, they don't conduct current. They don't conduct current simply because due to strong forces of attraction, that fix ions, preventing motion. So ions cannot move, and because of that, ionic compounds will not be in position to conduct current. When you look at the other part of ionic compounds, we are going to look at ionic compounds in molten state. If you get, let's say, sodium chloride and warm it or heat it until it reaches its melting point, which is roughly 800 degrees Celsius, the moment it melts, what will happen? So part B, we are going to look at molten state. When you have ionic compounds in molten state, these ones conduct current. And the reason is because heat breaks the forces of attraction. Making ions free to move. So if ions are free, as they move, they will carry charge along with them. And that's why we shall say that ionic compounds will be in position to conduct. Aqueous state, in this case, ionic compounds conduct current because of ionization, that makes ions free to move. So in that particular aspect, we shall see ionic compounds conducting electricity. So if I have a question here, how can we go about it? Explain why copper 2 chloride does not conduct current in solid state, whereas it conducts in molten state. So you simply have to come here, generate an explanation we made on solid state, and check the explanation we made on molten state. Therefore, our answer will be that copper 2 chloride in solid state has fixed ions due to strong forces of attraction, which are broken when heated to form free mobile ions in molten state, which conduct electricity. So it depends on how you want to back up your answer. However, the explanations that respond to such questions have been captured on this particular aspect. The next concept on electrolysis is what we call the ionic theory. And this one leads us into the typical details of electrolysis and how it takes place. We all know that electrolytes have positive and negative ions. The positive ions are going to be called cations, and the negative ions are going to be called anions. So electrolytes have positive and negative ions. Alternatively, we can say ions of opposite charge. When you connect current, these ions are going to be discharged, and the way they are discharged will be depending on the charge of the electrode. So the positive ions are attracted towards the cathode. If you still recall, we said the cathode is the negative terminal, while the negative ions are attracted towards the anode. In such a way that if this is my drawing to represent the electrolytic cell, I'm having a positive and negative terminal. According to my drawing, I will have an electrolyte placed into the electrolytic cell. If I try to label, this one will become my cathode, simply because it is connected to the short bar which represents a negative. And this terminal will be representing the anode. Within here, we shall have what we call the electrolyte, and this is our DC source. So the charges we are talking about, that when you connect current to an electrolyte, this electrolyte is going to dissociate and form ions. The negative ions are all going to be attracted towards the positive terminal, because unlike charges attract. And then all the positive ions are going to be attracted towards the negative terminal. And these ones are cations, while this side I have the anions. So in simple terms, at each electrode, that's how we are going to come up with the distinguishing factor in terms of cations, where they are supposed to be attracted, and anions, where they are supposed to be attracted. Now, to demonstrate the ionic theory, we can have an experiment to demonstrate the ionic theory, to clearly show us how the ionic theory can be explained. Now, in this experiment, get a microscope slide, place a crystal of a colored compound. On that crystal, place a wet filter paper on top of it such that it can dissolve. Then connect the microscope slide to a source of current. And that current, we should have a switch. The switch is always connected to the positive terminal. Then connect it. If I try to label, this is the DC source. This one becomes the switch. We have a microscope slide. This is, let's say, copper 2 sulfate crystal. We all know that copper 2 sulfate crystal in hydrated form is blue. This is a wet filter paper. So if you have your setup in that format, expect to see some few things. Observation that when we connect our switch, if the switch is connected, current will flow and it will cause our electrolyte, which is copper 2 sulfate, to ionize. The copper 2 sulfate ionizes, giving us copper 2 ions and the sulfate ions. Among these two ions, it's the copper 2 ions which make the compound to appear blue. And since copper 2 ions are positively charged, they are going to be attracted towards the negative end of the microscope slide. And this is our negative end. So our observation is going to be very simple, that the blue color spreads and moves towards the negative end of the slide. And if we are requested to suggest an explanation, in case of an explanation, the explanation will be very, very clear that the blue color we are talking about is due to copper 2 ions, which are positive. Thus, attracted towards the negative terminal. And this one tries to show us that cations which are positively charged are attracted towards the cathode. So if they request for a conclusion, if I request you for a conclusion from what you are seeing here, the first explanation tells us that cations are attracted towards the cathode. That is what we are generating from the very first observation of the blue color. If we change a bit here, instead of copper 2 sulfate crystal, we change that component and make it potassium permanganate. Potassium permanganate crystal. This crystal appears to be purple. You will realize that on ionization, potassium permanganate will give us potassium ions and manganate ions. These manganate ions are the ones that make the entire compound to appear purple. So when requested for an observation, since the ions that appear purple are negative, we are going to see them being attracted towards the positive end. Therefore, in our observation, we shall say that purple color spreads and moves towards the positive end of the slide. Therefore, in our explanation, the explanation will be clear that the purple color is due to manganate ions, which are negative. And because they are negative, thus attracted towards the positive terminal. In case I request for a conclusion, the conclusion will be very simple and sweet. Depending on what we have seen, our conclusion will be suggesting that anions are attracted towards the anode. So the conclusion will be signaling this to show you that all negative ions are going to come around the anode. So to further demonstrate this, if I have my electrolytic cell, we shall remove this very, very fast. And I put another demonstration to show you the ionic theory in details before we look at other areas. If this is my electrolytic cell, and I have two terminals, connected in that manner, and I'm having lead to bromide and this one is molten. This becomes our cathode, while this becomes the anode. When we try to expand this a little bit, lead to bromide is lead and bromine. Since the most stable oxidation state of lead is 2, so we shall find lead to bromide like that. When molten, it ionizes to give us lead to ions, liquid state, plus bromide ions, liquid. Lead to ions are positive, while bromide ions are negative. Now, if these two ions are present in our electrolyte, we shall see bromide ions. Trying to show this with a different color. Bromide ions will all be attracted towards the positive terminal, while lead to ions which are positive are all going to be attracted towards the negative terminal, which is the cathode. So that's how the splitting is going to happen in terms of the ionic theory. And this one takes us to mode of discharge, mode of discharge. Sometimes we shall say selective discharge, depending on what we want to use. To emphasize here, discharge of ions occurs at the electrodes. And since we have only 2 electrodes, in this case, we have the anode and the cathode. Our discussion will be very simple on that. On one side, I'm going to be having the cathode, while on the other, I'll be having the anode, and see how the discharge occurs in this case. If I have my anode, and the other side I have the cathode, we shall simply say the anode discharges anions, while this one discharges cations. This one discharge is by loss of electrons, while here discharge is by gaining electrons. And for those who followed us in the very first episode, we said loss of electrons is the same as oxidation. So we shall say oxidation occurs, while here reduction occurs. Therefore, whenever you want to identify an anode, simply follow where oxidation occurs. Oxidation occurs at the anode, while reduction occurs at the cathode. So sometimes we tend to abbreviate that we come up and say anode is oxidation, cathode is reduction. A standing for anode, O standing for oxidation, C standing for cathode, and R standing for reduction. So that's how you will easily identify an anode and a cathode. As we plan to conclude, we look at factors that affect all factors that determine selective discharge. These factors are 3, and each factor will be elaborated on in our next episodes. The first factor is the position of ion within the electrolyte in reactivity series. The other is concentration of ion in the electrolyte. And lastly, the nature of electrodes used. Each factor will make up a full episode such that we can basically understand each and every factor clearly. So we shall make 3 more episodes to elaborate on the factors that affect or determine selective discharge. As we end this episode, I'm leaving you with the question number 10, which clearly indicates what we have discussed in this very part of the discussion. I would like to end here and request you to continue subscribing, share the link with other members out there, such that they subscribe, watch, like, and comment on my videos. Thank you very much for following Smart Science.